Hi everyone, so we're going to get into the second part of our topic for stoichiometry, and we're going to talk a little bit about limiting reactant. So limiting reactant is an extension of stoichiometry, and it really, for the most part, should make sense to you because, we don't always have enough of everything to finish things off or make a reaction to go to completion. A simple analogy could be that it requires 4 tires for every tractor to be built. So if once you run out of tires, and you have all the other parts to finish off building the tractor to its finality, the tires are going to limit the number of tractors that can be produced. Same thing in the chemical world, and just like our chocolate chip cookie recipe. So if we didn't have enough of an ingredient, if it required 2 eggs to make those 5 dozen cookies and all we had was 1 egg, sure, we could still make chocolate chip cookies. We'd have to change the amounts of all the other ingredients, correct? But it would affect the total amount of chocolate chip cookies that we could make in the end. So limiting reactant is the reactant that limits the amount of product that can form in a chemical reaction. All right, so the limiting reactant, or LR, so that's a simple way to look at that. You might see me using that as a little acronym. It's completely used up in a reaction, and it's going to determine the physical amount of product that can be made. Whereas the excess reactant, or EXR, you might also see that, is not completely consumed in the reaction, and some of it will remain when the reaction is complete. You've seen excess reactant in quite a bit of your little stoichiometry problems. The language of the sentence will say something about how, and excess this. Well, that's just describing the thing that you're going to have extra of. But now we're going to actually be doing calculations to figure out the identity of the limiting and the excess reactant. It won't be discussed with us in the components of our problem. All right, so there are some general steps in solving for limiting reactant. So basically, you pick a product to work with. And we all know that for most of the problems that we do, there are at least 2 products. All right? Most of the time, the question will give you the product it would like you to focus on. So anytime the statement and the question give you a product that they're questioning you about, go ahead and choose that one to work with. Truth is, you could use any product, but you don't want to do extra footwork if you already have something to focus on. If the reactants are already in grams, you're going to have to convert them to moles. Remember, moles is our language for chemistry. It is the measuring unit for chemistry. So if you're in grams, go ahead and convert those grams to moles using molar mass. And then from there, you're going to convert each reactant to moles of the product form. Now, my personal deal is I go ahead and just convert each of the reactant to grams of product, because then I've done 2 bridge work total and I can answer a number of questions from that. But you can go ahead and stop at moles because that will help you determine. The smaller answer will let you know who the limiting reactant is, and then it will help lead you to the amount of product that can be made. And so the 5th step is to take the smallest answer for moles and convert it to grams. And that's why I just kind of go ahead and combine, 3, 4, and 5 together. I just go ahead and do all the way to grams of that product, and that way I can answer the rest of my questions from that. So let's look at a simple analogy. You own a sandwich shop, okay? And the general sandwich, we have 2 slices of bread and a nice thick slice of ham. Okay, so in our little chemistry world, that's 2B plus 1H equals 1B2H. Look at that ham sandwich glow, right? Okay, so what if we looked at the amount of product, the amount of materials that we had for our day as we open up our sandwich shop, and we realize we've got 54 slices of bread and we have 40 slices of ham. Now, I think all of you know right now that we could really do this problem without having to do math work. I think we could look at these numbers in our head and come up with the answers, but let's just go ahead and work with that little bit of conversion using our balanced chemical equation so that we can see what the steps of our process will be. Okay, so do you guys notice something here? We've got two givens in our sentence. See, we've been used to working with one numerical piece of data, and now we have two. Not only do we have the amount of bread that we also have been given the slices of ham that we have. So that's the first of that we've seen, is that we have two pieces of numerical information that we must convert. Now remember, pick a product to work with, doesn't matter which one, but the beautiful part in this case is that we only have one product, and that is 1B2H, that full ham sandwich. So, ooh, look at that sandwich. So let's go ahead and just do a little bit of work. Remember, our next step is that if we're in grams, we go ahead and change each to moles. We'll go ahead and assume for this little problem that the sandwich material is already in the language of moles. So we have each reactant, and we're going to calculate the moles of product that we can make from each reactant. That means I'm going to take this amount here, ratio, and compare it to this ratio in one problem using 54 slices of bread as my given. And I'm going to have a second problem where I take this part of my reaction, the mole ratio here, and cross compare it to the mole ratio of my product. And that will be with the 40 slices of bread. 40 slices of ham. Okay, so our first statement was the 54 slices of bread. So 54B, and my ratio, okay, is for every full sandwich I have, it requires 2 slices of bread. So it's a 1-to-2 ratio, which means I could make 27 sandwiches, which I think most of you knew to take 54 divided by 2 to let us know we'd get 27. But again, we wanted to tie in that whole idea of using a balanced chemical equation and the mole ratio to do our math work. Okay, so now our other reactant was 40 pieces of ham. So we're going to do the same thing. We're going to take that 40, and for every 1 slice of ham or 1 mole of ham, I can make 1 whole sandwich or 1 mole of ham sandwich. And so that is a 1-to-1 ratio, and I can make a total of 40 sandwiches, which I think all of you knew that instinctively at first, is that each slice of ham can make a whole sandwich. Now here's what our last thing we want to do is, who limits the amount of sandwiches we can make? The bread does, right? We can only make a maximum of 27 sandwiches with the amount of bread that we've been given to work with, but we have the potential of making 40 sandwiches. The problem is we ran out of bread. So we'll never make 40 sandwiches. We'll only make 27 sandwiches. The smaller answer from this simple math work will tell you the maximum amount of product that you can make. The maximum amount of product we can make is 27 sandwiches. We can theoretically make 40, but we just don't have enough of the other reactant. We've run out of it. And I think this is everything we just compared here. We talked about making, yep, got that. Beautiful. Awesome. Thank y'all very much.